Today we're going to be talking about rates of change and derivatives. Mr. Kwan is racing to get to Kim Kardashian's baby shower because he heard that there is going to be free sushi there, not because he has any vested interest in her baby. Kim's baby shower is 9 miles away from his house, and he needs to get there as soon as possible, so he goes speeding down the streets in his mom's station wagon. The graph below shows how far Mr. Kwan traveled after certain amounts of time. All right, so we have this graph here. So notice the horizontal axis represents time in minutes, and the vertical axis represents distance in miles. Now, before I go into these answers, I'd like you to try and answer these questions yourself. So go ahead and pause this video and try to answer all of these questions on your own before I start to talk about them. Okay. Part A says, is Mr. Kwan traveling the same speed his entire trip to Kim's house? How do you know? If you said yes, why do you think that? Notice here we have kind of two linear functions. So there's a function here and then a new linear function here. And I know that they're not made up of the same function because they have different slopes. And so the way that we calculate speed is calculated by taking the distance traveled and dividing that by time. And so here, the amount of distance that I traveled in this first leg is not this, and if I divide that by time, that's not the same with the distance over time in that scenario. And visually, how I can see that is because of the slopes of both of these lines. The slopes are not the same, so that tells us that I'm not traveling the same speed during the entire trip. So that is the answer to part A. Part B says, calculate the speed that Mr. Kwan traveled during the first 5 minutes of his trip in miles per hour. So that's important, the miles per hour, because the time is given in minutes, so we have to think about that. Okay, so again, speed is equal to distance over time, and during the first 5 minutes, I want to look at this point here. That ordered pair, 5, 6, means that after 5 minutes, I have traveled a total distance of 6 miles. So my speed during the first 5 minutes would be 6 miles divided by 5 minutes. However, I need to convert that in miles per hour. So what I'm going to do is I know that there are 60 minutes in 1 hour. And if I multiply these values here, the minutes and the minutes will cancel out. So I just want to multiply 6 miles times 60 over 5 times 1 hour. And if I do that, let's see, my handy dandy calculator. So I have 6 times 60, so that's 360, and then I want to divide that by 5. So that means that I am traveling 72 miles per hour. So 72 miles per hour. That is my speed during the first leg of my trip. And hopefully you recognize, because the line is steeper here than it is in the second part, that means that I am traveling faster in that first part than in that second part. And notice that my speed changes right around 5 minutes. So maybe what ended up happening, if we're gonna create a conjecture, maybe what ended up happening was after 5 minutes, I saw a police officer in his car sitting and waiting with his little speedometer gun. And so I didn't want to get a ticket. So after 5 minutes, I slowed down. Maybe that's what happened. I know that I do that in real life sometimes when I'm driving on the freeway and I see a cop pulled over with their little, their device or their instrument that measures speed. I slow down a little bit. Okay. Anyways, part C says, calculate the speed that Mr. Kwan traveled between right after 5 minutes to the end of his trip in miles per hour. So I need to calculate the speed here. And the way that I'm going to calculate that is, again, the distance traveled over the amount of time. So notice here that we're measuring between 5 minutes and 15 minutes. So the time that's taking place is going to be 15 minus 5, which is equal to 10. So that part of my trip is happening over a span of 10 minutes. Now, I want to figure out how much distance I traveled. And the way that I'm going to do that is I know after 15 minutes I've traveled 9 miles, and after 5 minutes I've traveled 6 miles. So during that leg of the trip, I've traveled 9 minus 6, which is, if you simplify this, let's see, so this is in miles, and this is in minutes. So if I simplify that, we get 3 miles over 10 minutes. And again, I need to convert that into miles per hour. So I know that there are 60 minutes in 1 hour. And so if I multiply all of that, the minutes will divide out. And so let's see, 3 times 60 is 180 miles per, and then 10 times 1 is 10 hours. And if I simplify that, that is equal to 18 miles per hour. So 18 miles per hour. That is our answer for part C. Hopefully this thing here, it kind of looks familiar. And if you're like, oh, that does look familiar, it's basically coming from the slope formula. What we're doing basically is we're calculating the slope of this line here. And remember that slope is equal to y2 minus y1 over x2 minus x1. So if you were like, hey, that looks familiar, that's because basically that and that are the same thing. We're calculating the slope of that line segment there. Part D says, is it possible to figure out Mr. Kwan's average speed over the entire trip? If it is possible, calculate his average speed. If it is not, explain why. Okay, so it is possible, and basically we just want to know over the entire trip how much distance did I travel and how much time did I spend. So the first part of the trip is starting at 0, 0. So basically I have not traveled any distance and I have not traveled any time. And then I end up, this ordered pair here basically tells me that I have traveled 9 miles in the span of 15 minutes. So normally, I would still use the slope formula, m equals y2 minus y1 over x2 minus x1. And so if I did that here, that would be 9 minus 0 over 15 minus 0, so it's 9 over 15. And that's just telling us that over the whole entire trip, I've traveled 9 miles in the span of 15 minutes. Now I'm going to erase that really quickly and just illustrate what that is that I'm calculating. This here, so let me pull out my ruler. So I'm connecting these two ordered pairs, the first one and the last one basically, with this red line. And this is a special line called a secant line. And basically I am calculating the slope of that secant line, connecting the two ordered pairs that we are concerning ourselves with. And like I said, we're calculating the slope of that secant line, and that will give us the average speed. So average speed is equal to the slope of the secant line. Okay, so again, I calculated the slope formula earlier. That was 9 miles over 15 minutes. but I still need to convert that to miles per hour. So I'm going to multiply that by 60 minutes over 1 hour. And if I multiply those, the minutes divide out, and that is, let's see, 540 miles per 15 hours. And then if you divide that, you end up getting 36 miles per hour. So 36 miles per hour. That is the final answer for part D. Now, I've given this activity in the classroom to students before, and I've had a few students, what they'll do is they'll take this number and take the average of those two numbers, which if you take the average of them, you do 72 plus 18 over 2, and that's 90 over 2, which equals 45. And they'll ask me, Mr. Kwan, why can't we take the average of these two numbers to get the average speed of the overall trip? So I will let you think about that. That's an interesting question to pose. So again, let me ask that question. If I wanted to find the average speed of the entire trip, why can't I just take the average of these two numbers? So think about that and mull it over.